Hello, this is Stephen Neshaba, and I'm here to help you out with a couple of items on our computational lab. This is a kind of recap of that lab. So I just want to take you through these last two items, which have to do with identifying hydrophobic and hydrophilic parts of given amino acids, and to identify given amino acids as D or L. So let's go straight to Spartan here. I brought up alanine. And one of the first skills to acquire when you're looking at amino acids is recognizing the different parts of it. So here it's fairly straightforward in that there's this central carbon. It has a hydrogen on it. It has a CO2 minus on it. Now, for the purpose of talking about that, it's convenient to have a name for this part of the amino acid, and it's called the C-terminus of the amino acid. Here's the NH3 plus part that's attached to that same central carbon, and that'll be called the N-terminus of this amino acid. And since this carbon has a C-terminus and an N-terminus and a single hydrogen and something else, that makes this an amino acid. The something else, which is pointing down and away from us, that is the R group, and we can see that the R group is CH3, and that makes this a alanine, because the alanine is defined as having an R group of CH3. Now, there's one more little piece of this well, two more pieces of this. One, I just want to go to what happens when we put water molecules around that. You can probably predict, I hope, that the C-terminus and the N-terminus will be pretty hydrophilic because they can make hydrogen bonds, but the CH3, that looks a little bit like methane. It's hydrophobic, and if we go to what this looked like when I put some water molecules around it, you can see there's the N-terminus forming a hydrogen bond. Here's the C-terminus forming a couple of hydrogen bonds, and the R group did not form any hydrogen bonds. So let's see, and now the last sort of point about this one is this L-alanine or D-alanine? And the way to get that is, now that you are pretty familiar with identifying the alpha carbon, you orient it, as I have here, with the hydrogen pointing straight up at you and the R group down and away from you. And you'll notice that now the N-terminus is at 10 o'clock and the C-terminus is at 2 o'clock or so, if you imagine this as a steering wheel, and or if you like, the N-terminus is up and to your left. So that makes this L-alanine. And now to just give you a little practice, I have another alanine here, and let's see if you can figure out whether this is L or D-alanine. Okay, it's a little bit, requires some three-dimensional visualizing, but you can tell that there's the alpha carbon, I hope. There's the hydrogen pointing to that hydrogen. There's the R group, C-terminus, N-terminus. If you can't do this rotation in your head, which takes a bit of practice, you can always do it in Spartan. And so I'm going to try to arrange things now, as I said before, so that the R group is down and away from us. The hydrogen attached to the alpha carbon is pointing straight at us. And now you notice that the N-terminus of this alanine is at 2 o'clock. It's up and to the right, and that makes this D-alanine. Okay, I'm just going to take us to aspartic acid, and let's see if you can just identify where the alpha carbon is. Okay, or the alpha carbon is right there in the middle, and now this amino acid is actually already oriented in the way that we can easily identify whether it's D or L. Why don't you give that a try? Okay, I hope you notice that the hydrogen's pointing up at us, the R group is down, the N-terminus is at 10 o'clock, and that makes this L-aspartic acid. And I won't show you the D at the moment, but I did want to show you the solvated form. Now, of course, you probably expect that this will be hydrophilic. This part will be hydrophilic too. In this case now, because the aspartic acid has an R group that has a CO2 minus on it, you can expect that the R group itself will be hydrophilic in addition to the C terminus and N terminus. And I've just kind of brought up a solvated form of this, and you can kind of see that's the case, right? This is there's the C terminus, and there's the N terminus. Both of those are experiencing hydrogen bonds, and then there's the R group of aspartic acid, which is also having some hydrogen bonds to the solvent. So the last one I just want to show you here is serine. And why don't you give this a try? Tell me, identify the alpha carbon and whether this is L or C, although I've kind of given it away here, whether it's L or D. Okay, so here we have the alpha carbon, C terminus, N terminus. That's obviously the R group, which is a CH2OH. Certainly, this serine would have a it would be hydrophilic. The R group is hydrophilic because of that R group, that OH on the R group, in addition to the C terminus and N terminus. So if you've been studying this, you probably already figured that out, that this must be L-serine because I've got the N terminus up and to the left. And now here's just for comparison D-serine because now the N terminus is up and to the right. All, of course, predicated on the arrangement of it such that the hydrogen on the alpha carbon is pointing toward you and the R group being down and away from you.